You call a NumPy function and C star args, kwargs in the signature. You look at a decorator and wonder how wrapper passes arguments to the original function. You subclass a class and are not sure how to forward and knit arguments to the parent. I am Mahas. Today in episode 29, star args and kwargs, you will learn the single most important argument pattern in all of Python. We will cover star arg for packing positional arguments into a tuple, kwargs for packing keyword arguments into a dictionary, the correct order when combining them, the unpacking operators star and in function calls, forwarding arguments through wrappers and decorators, and real patterns used in NumPy, Flask, and PyTorch every day. By the end, you will build a flexible data pipeline that accepts any combination of inputs. Let's go. Let's start with the problem that star arg solves. You write a function called add that takes exactly 2 numbers. It works, but it only works for 2 numbers. What if the user wants to add 3 or 10? You could add more parameters, A, B, C, D, but how many is enough? Look at the left side, the rigid version. Add takes A and B. Call it with 3 arguments, type error. Look at the right side, the flexible version using star args. Add takes star nums. Now you can call it with 2, 3, 10, or 100 arguments. All of them arrive inside the function as a tuple called nums. This is the core insight. Star before a parameter name means collect all remaining positional arguments into a tuple. Python's built-in sum, print, and max all use this pattern. So does every NumPy and PyTorch operation you will ever call. Let's understand star args deeply. The star in the parameter definition is the packing operator. It says, collect every positional argument the caller passes and pack them into a tuple. Look at the code. We define a function called show_args with parameter star args. Inside, we print the type of args. It is a tuple. We print args itself. We loop over args and print each item. When we call show_args with 1, 2, 3, args becomes the tuple 1, 2, 3. When we call it with no arguments, args is an empty tuple. When we call it with 100 arguments, args has 100 items. 2 rules to remember. First, args is just a convention. You can name it anything after the star. Star numbers, star values, star items all work. Second, you can have regular parameters before star args, but nothing positional after it. The star parameter must come after all regular positional parameters. Now let's learn kwargs. The double star in the parameter definition is the keyword packing operator. It says, collect every keyword argument the caller passes and pack them into a dictionary. Look at the code. We define configure with parameter kwargs. Inside, we print the type. It is a dict. We loop over kwargs.items to see key value pairs. When we call configure with host equals localhost and port equals 8080, kwarg becomes a dict with those 2 entries. When we call it with 10 keyword arguments, kwargs has 10 entries. 2 rules here too. First, kwargs is just a convention. Double star options, double star settings, double star config all work. Second, double star kwargs must always be the last parameter. You can have regular perms, then star args, then double star kwargs. That is the only valid order, and Python enforces it strictly. Flask's app.route, Django's model fields, and FastAPI's query parameters all use double star kwargs to accept arbitrary configuration. You can combine regular parameters, star args, and double star kwargs in one function. But the order is strict. Python enforces it. Look at the code. We define a function with 4 parameter groups. First, required, a regular positional parameter. Second, optional with a default value. Third, star args, collects all extra positional arguments. Fourth, double star kwargs, collects all extra keyword arguments. This is the maximum signature. Every Python function fits somewhere in this pattern. We call it with required equals A, B, and C as extra positionals, and X equals 10 and Y equals 20 as keyword arguments. Required gets A. Optional stays at its default. Args becomes the tuple B, C. Kwargs becomes the dict X10, Y20. If you flip the order, star args before a regular param, or double star kwargs before star args, syntax error. The rule: required, defaulted, star args, keyword only, double star kwargs. Memorize this order, and you will never hit a signature bug again. So far we have seen packing, collecting arguments into a tuple or dict. Now we learn unpacking, the reverse. The same star and double star operators work in function calls to unpack sequences and dicts. Look at the left side, star unpacking. We have a list called nums with 3, 1, 4, 1, 5. We call print with star nums. Python unpacks the list and passes each item separately. We call a function add with star nums. Same thing. Look at the right side, double star unpacking. We have a dict called config with host and port keys. We call connect with double star config. Python unpacks the dict and passes host and port as keyword arguments. You can unpack multiple structures in one call. Star list 1, star list 2 passes items from both. Double star dict 1, double star dict 2 merges both as keyword args. This pattern is everywhere. Passing dataset options to torch.dataLoader, spreading request headers into request.get, merging configuration dictionaries without writing update loops. Forwarding arguments through wrappers is where star args and double star kwargs become truly essential. Look at the code. We have a decorator called timer. The wrapper function takes star args and double star kwargs. It forwards them to func by calling func with star args and double star kwargs. This is the correct way to write every decorator. Without star args and double star kwargs, the wrapper only worked for functions with exactly matching signatures. With them, the wrapper works for any function. No arguments, 1 argument, 10 arguments, mix of positional and keyword. Now look at the subclass example below. Our manager class inherits from employee. The manager dunder init takes its own parameter, department, plus star args and double star kwargs. It extracts department, then forwards everything else to employee via super dunder init with star args and double star kwargs. This is the correct subclass pattern. You see this in every PyTorch module subclass, every Django model, every Flask view class. Let's look at 3 real-world patterns you will use constantly. First, flexible logging. We define a log function that takes a level, then star arg for the message parts, then double star kwargs for extra context like user ID or request ID. One function handles every logging case in your application. Second, dict merging with double star unpacking. We have base defaults and user overrides. We merge them with double star base, double star overrides, and a new dict literal. User values override base values automatically. This replaces base.copy followed by base to update every time. Third, pass-through builder. We wrap torch.dataLoader, or any heavy constructor, in a function that sets sensible defaults but accepts overrides via double star kwargs. The caller can override any parameter without us exposing every argument explicitly. These 3 patterns cover 90% of star args and double star kwargs use cases in real Python projects. Before we build a project, let's look at the 4 most common mistakes. Mistake 1. Wrong order. Star args must come before double star kwargs. Putting double star kwargs first is a syntax error. Mistake 2. Modifying args in place. Args is a tuple. It is immutable. If you need to modify it, convert to a list first. Mistake 3. Assuming args is always populated. If the caller passes no extra positionals, args is an empty tuple, not none. Always check with if args, not if args is not none. Mistake 4. Name collision in double star unpacking. If you unpack 2 dicts that share a key, Python raises type error. For example, double star dict A, double star dict B. If both have a key called host, type error. Merge manually with a comprehension if keys can collide. Recognize these 4 patterns and you will never hit an args or kwargs bug again. Our mini project, a flexible data pipeline builder. This is the pattern used in Pandas, scikit-learn, and every ML pre-processing library. Look at the code. We define a pipeline class. Dunder init takes star steps, any number of transformation functions. It stores them as a list. We add an add_step method that appends more steps later. The run method takes *args and *kwargs, the input data. It feeds the data through each step in sequence. Each step receives the output of the previous step. We define 3 transformation functions: normalize, clip, and label. Normalize takes *kwargs and normalizes values to 0-1 range. Clip removes outliers beyond a threshold. Label tags results as high or low. We build the pipeline by passing normalize and clip to pipeline. We add label as a third step. We run the pipeline with our raw data as a keyword argument. The result flows through normalize, clip, label, clean, and labeled. This is *args and *kwargs at their best. Maximum flexibility with 0 boilerplate. Your challenge: build a flexible function toolkit. Step 1. Write a function called merge_configs. It should accept any number of configuration dictionaries as positional arguments. Later dictionaries override earlier ones. Return the merged result. Step 2. Write a universal decorator called trace. It should print the function name, the args tuple, and the kwargs dict before every call. It must work on any function regardless of signature. Step 3. Write a class called eventBus. It has a method called emit that takes an event name and *args and *kwargs. Registered handlers for that event name get called with those arguments. Step 4. Add type hints to all 3. Step 5. Run mypy-strict. 0 errors required. Paste your toolkit and mypy output in the comments. I read every single one. Let's recap what you learned today. *args packs extra positional arguments into a tuple inside the function. *kwargs packs extra keyword arguments into a dict inside the function. The correct order is required defaulted *args, keyword only, *kwargs. In function calls, unpacks a sequence into positional arguments. *unpacks a dict into keyword arguments. In wrappers and decorators, always use *args *kwargs to forward arguments. In subclasses, forward to superdunder init with *args *kwargs. Real patterns, flexible logging, dict merging, pass-through builders. Common mistakes: wrong order, modifying the tuple, key collision, and *merge. The mini project built a flexible pipeline that accepts any input combination. Next episode: functional tools, map, filter, zip, enumerate, lambda, functools.partial, and reduce. Subscribe so you don't miss it. See you tomorrow. *args and *kwargs, mastered. Every Python library you call is now fully readable. Subscribe for the next episode. Drop your toolkit in the comments. I am Mahaz. See you in episode 30.